Recording. Okay, start broadcast.
The broadcast is now starting. All attendees are in listen-only mode.
Okay, good afternoon everybody. My name's Warwick Rudd and welcome along to this afternoon's DBA Fundamentals virtual chapter in the Australian time zone. Now, this is the first session of this. We are working with the DBA Fundamentals virtual chapter based in the States, and we're looking at getting our own virtual chapter out here in Australia for you. Now, in today's presentation on SQL Server Performance Tuning, Controlling Parallelism, we've got our presenter Robert Davis from the States, and I'll hand over to Robert in a minute, but I just wanted to go through a little bit of housekeeping first off. Now, as I did just mention, today is the first session that we are running this virtual chapter in the Australian time zone. To help us gauge what is happening with you guys and how many people are attending, I'm just going to launch a poll for you, and if you can fill out that poll telling us where you're from, which continent you're from, because that will help us continue track over time who is coming along to this virtual chapter. Now, our next session next month is going to be on the 12th of October 2015, and we've got Jimmy May presenting on SQL Server on Flash, Rethinking Best Practices. So be sure to keep an eye out for the registration for that, and it'll come through shortly, and we hope to see you next year, or I shouldn't say next year, next month. Now, feel free to ask any questions throughout the presentation, and depending on what the question is, we may answer it there and then, or it'll get deferred and Robert will answer those questions for us at the end of the presentation. So without any further ado, I'll hand over to Robert and we'll get the presentation underway.
Hey, Warwick, it says you have to close the poll before you can give it to me.
Okay. There we go, closed.
Okay, great. Hopefully everybody can see my screen now. As Warwick said, I'm going to be talking today about controlling parallelism. A little bit about myself. My name is Robert L. Davis. I'm a principal database architect for DBAs Technologies. I am a certified master in SQL Server and a SQL Server MVP. You can find my blog at sqlsoldier.com, and I will be speaking at the PASS Summit this year, so I hope to see some of you there. You can also find me on Twitter as SQL Soldier. One of my favorite analogies for explaining how parallelism works, and a lot of people use this analogy, is the jelly bean analogy. If I gave you a handful of jelly beans, how long would it take you to count it? Well, if it's a small handful like this, probably not very long. But if I gave you a big jar of it, how long would that take you? That's going to take you a while if you're just counting by yourself. And what if I give you 4 big jars for you to count all by yourself? It's going to take a good long while. But let's say you have 3 friends, and so you decide to break it up into individual bowls, and you each count 1 bowl and then add up your totals at the end. That's basically how parallelism works in SQL Server. It separates the workloads into separate tasks, and then combines everything together at the end. So that's one of its optimizations for speeding things up. So parallelism is a good thing. Now, to really understand parallelism, I think you need to understand architecture of the CPUs and how specific tasks run on them. So this is a little diagram of a typical CPU structure you may see in SQL servers today. This particular one has 2 NUMA nodes. with 4 CPUs per NUMA node. And within the SQL OS, you're going to have a scheduler for each of those CPU threads. Each of those CPUs has one thread, and so for every CPU thread, there's a scheduler. So it's a one-to-one relationship in this case. And each of those schedulers have a bunch of worker threads attached to those. So if we zoom in a little bit on that, we can see and zoom in on just a single NUMA node. The picture is a little easier to understand. You can see that those ones at the bottom say worker thread. Zoom in a little more, or we consider the case where the CPUs are hyper-threaded. We still have 4 physical CPUs, but let's say we've enabled hyper-threading, so now we've got 8 logical CPUs. So the actual number of physical CPUs hasn't changed, but it does have twice as many CPU threads now, and therefore we've got twice as many schedulers. So now we've got 8 schedulers for those 4 CPUs, giving us a total of 8 CPU threads we can run things on. And then again, a bunch of worker tasks attached to those schedulers. Zoom in a little bit on the scheduler so we can, get a good look. It's got a bunch of schedulers attached, or worker threads attached to a scheduler. And this actually isn't to scale. This is just done to make it easy to read. If I was to do this diagram to scale, it would actually look more like this. The max worker thread setting, if you've left it at the default and you've got 8 logical CPUs, it's going to create a maximum of 576 worker threads, which comes out to 72 worker threads per scheduler. So as you can see, the scheduler actually does a tremendous amount of work. It's responsible for, in this case, 72 worker threads, and it has to get all those threads to cooperate together, give each one a little bit of time on the CPU to run, and so that each task gets its time on the CPU. And it has to control all that sharing, keep track of whose turn it is and everything. So that scheduler actually works very hard in SQL Server. So let's look at how queries line up on those schedulers as you have queries starting to run. So let's say you have 8 schedulers here for a system, and you have 2 queries already running. They're going to run on the first 2 schedulers because the way queries are assigned to a scheduler is they're done in round-robin fashion. First one will go to the first one. The second one will go to the second one. Third one will go to the third one, and so on and so on. As far as based on where these threads queries start at. So let's assume that we're going to start 2 additional queries. We're going to start a parallel query and a serial query. As I said, they'll go to the next available scheduler based off of where the last query was started from. So the first one that starts will go into scheduler 3, and the next one that starts will go into scheduler 4. So, but then the question is, let's say one of those queries that started is going parallel. So let's say it parallelizes out to a total of 4 threads. So the question is, where are those threads going to go? Are they going to go to schedulers 5, 6, and 7, or will they go to will they stay in order after the scheduler the query started on and go to 4, 5, 6? And if you guessed schedulers 4, 5, and 6, you're correct. So for parallel threads, they go immediately in line with the next scheduler after the one that it started on, and without any regards to any other queries that have started. So they stay right next door in line with the parent thread. And you can see how things can quickly, when you have a bunch of queries starting, things can start to get uneven. We've got one scheduler in the middle that's got 2 threads running on it, one scheduler way down at the end that's got nothing running on it, and then a bunch of others that just have 1. So we can expect the activity running on that scheduler number 4 to take a little longer than all the others, because it's having to share CPU time with each other. So let's say a new query starts up, all that is running. There's one of two places it can go. It can go to the scheduler number 5, which would be the next one that after the last new query started, or it could go to the scheduler number 8, which would be the next one after the last thread that started. And if you guessed that it would go to scheduler number 5, you're correct. It goes to the next scheduler in line based on what scheduler the query started on. It ignores the fact that parallel threads have started and will start on that scheduler number 5. So now we've got 2 schedulers with 2 tasks running on it and one that still has nothing. Now let's look at the scenario where this is actually split into 2 NUMA nodes. And let's say we're starting off where we were before. We had 2 queries running. We have a new query that's parallel starting on scheduler 3, and a new query that's serial starting on scheduler 4. So that's what we've got running now, and it needs to parallelize those threads out. Now it can either do it here, go in line and the same way it did without the NUMA nodes, go to 4, 5, 6, and 7, or maybe it'll just wrap around and stay on that same NUMA node and be on 4, 1, 2, and 3. And if you guessed that it would go to 1, 2, 3, or go to 4, 1, 2, and 3, most of the time you're right. And it actually depends on this answer. There are some cases where if one NUMA node is extremely stressed and the other isn't, it will spread the parallel threads across NUMA nodes. But greater than 99% of the time, it's going to keep those threads on the same NUMA node. So this is why we give the recommendation to not exceed the number of CPUs per NUMA node for the degree of parallelism setting, because you don't want to have threads for a single query wrapping around and sharing the same CPU with itself, because that's just creating more overhead to process it as separate tasks than it would be to do it as fewer threads. So as an example, if it had parallelized out to 6 additional threads instead of 4, you can see here we've now got the parent thread on scheduler 4 and a parallel thread on scheduler 3. We've got a serial query and 2 parallel threads on scheduler 4. We've got 2 parallel threads on scheduler 1. I can tell you right now that scheduler 2 and 3 are going to be done with their work about twice as fast as the queries running on scheduler 1 and 4. And the way parallelism works is all threads keep running until all threads are finished. So you're going to have 2 threads that are basically sitting there on the CPUs doing absolutely nothing except taking up CPU time waiting for the other threads to finish. This is a case where parallelism has become a problem because we've over-parallelized it. We're causing threads to sit there doing nothing, waiting for other threads to finish because we're doubling them up. So as I said, SQL will generally keep all threads on the same NUMA node. If a node is overloaded and the other node isn't, it may choose to span nodes. That's actually a very difficult case to force it to do. You have to really have one node really overworked and backed up and the other one not. So it's really a rare case where that happens. Memory is partitioned per NUMA node. Even though it's accessible to all nodes, each NUMA node has memory that is directly connected to it, and we call this local memory, and it's very fast. And then if it has to connect to memory on a different NUMA node, we call that foreign memory access, and it's memory, so it's still fast, but it's a lot slower than local memory access. So if you are having to do foreign memory access, it is going to, again, it's going to slow things down. So you don't want a single query to span multiple NUMA nodes if it can be helped anyway. So as I said, local memory access is faster than foreign memory access. Old NUMA, before the Nehalem chips came out, if you were pulling from memory on another node, it first had to pass off the request to the other node, the other CPUs, and the CPUs would get on the other node would get the data from memory and pass it back to the requesting node. On the current NUMA, all the Nehalem and newer chips, memory manages the request to other partitions of memory and then sends it directly to the CPU, so it bypasses the CPUs on the other NUMA node. So foreign memory access is a lot faster now than it used to be. And so that's why in the early days of NUMA node, before Nehalem chips, there were a lot of recommendations to disable hyperthreading, because if you had a lot of foreign memory access, it could cause you a lot of problems. Nowadays, foreign memory access isn't nearly as bad, and if you do get foreign memory access, you're not going to feel the pain nearly as much. So definitely now the benefit in most cases is much better with using hyperthreading than not. There are some cases, some specific workloads where having hyperthreading on is still a little bit slower than turning it off. And really the only way to tell that is to test the workload with hyperthreading on and with it off and see which one's faster. So the main parallelism setting that everybody talks about is max degree of parallelism. It's a server configuration, and when we advise people on what to set this to, what we're really giving you is a starting point. This is where you start from, but you really need to look at your workload, see how it's handling the degree of parallelism it's got. The more parallelism you have, the lower your concurrency is, because it can only run so many threads efficiently at a time. So the more threads you have, the less tasks that can be running at the same time. So it's really about finding the right balance between speed, processing the queries, and concurrency. So the standard recommendation is if you have 8 or less CPUs, leave it at 0. Nowadays, a lot of people are choosing to not leave it at 0, even if they have 8 or less. For example, if they have 4 CPUs, a lot of people are choosing to set it to 4 because Enterprise Edition does support hot adding hot add CPU to servers. And also with VMs, it's very easy to get your server's CPU bumped up. And so if you've got 8 CPUs, and you don't want somebody else on the team to come along and say, oh, this server needs more CPUs, bump it up to 16, and now the queries are starting to over-parallelize, and nobody understands why it's suddenly the queries are running slower with more CPUs. So a lot of people, especially on VMs, are choosing to set that to the number of CPUs if they have 8 or less. If you have more than 8 CPUs, set it at 8. They have shown through many tests that parallelizing above 8 seems to create problems for SQL Server. There are, of course, exceptions to that come through testing of your workload, especially in like data warehouses. You may see it set to a higher number than 8 because they have a lot of really big monster-sized queries. But in general, you want to start off with no more than 8, and only use a higher number if you've tested it and proven that it actually works better with the higher number. And of course, and as I said earlier, if it's a NUMA machine, which most of them are these days, then you want to use the lesser of the number of CPUs per node, or 8, whichever is lower. You can override that server configuration setting by using the Max DOP query hint. I'm not a fan of using query hints unless you have to. There are certainly situations where you may want to do this. For example, I'll use this hint frequently in like index maintenance if I'm rebuilding an index. But usually when I'm doing that, I'm reducing the degree of parallelism, not going higher. But I'm doing that so that I know that the index can rebuild without using up all the resources on the server. On the other hand, if I have a downtime maintenance window, I may want to use the query hint to bump that up to a higher level, simply so that I'm not worried about how many resources it used, but I want it to finish as quick as it can so that it can fit within the maintenance window. So I may bump it up in that case. And both of these are overridden by the resource governor. And overridden kind of should have an asterisk by it, because I'll get into a little bit how it's not exactly overridden by resource governor. What it really boils down to is if there's a conflict between resource governor and the query hint, SQL Server will take whichever number is lower. So the query hint can't force max degree of parallelism to go higher, nor can resource governor make it go higher than what's put in the query hint when both of them are present. So whichever one is lower is what the query is going to run with. So the lesser of those two is what if they're both set. And I do have table. I was thinking about putting together like a flow chart showing the thought process it goes through to figure out what the effective degree of parallelism is. Then I found this nice chart on Jack Lee's website and decided to use that instead. I'm not going to go through all that because it boils down to max degree of parallelism and the query hint, the resource governor and the query hint both override the server setting, and when both of those are set, it takes the lesser of the two. There is another parallelism setting that is used less frequently, and not a lot of people really understand well what it does. It's called cost threshold for parallelism. All operations within an execution plan are assigned an estimated cost value. And to us, when we see the number, it looks like an arbitrary number. We can use it for like comparisons to see which operations have the higher costs, but it doesn't really equate to anything. It has a lot of meaning to the query optimizer, and is very reliant on the amount of I/O disk, or the amount of I/O things that's going to memory and disk. But it's really just, to us, it's just an arbitrary number. We can't look at that number and say, oh, that means such and such I/O. But it's really based loosely on the CPU ticks of a long-forgotten developer's desktop who worked on the feature. So this was, eons ago. So it's really not a relevant number other than the query optimizer knows what to do with it. And the query optimizer will look at the total cost for a serial plan, and if it's above that cost threshold for parallelism, it will then say, oh, okay, this is a candidate for parallelism, and it will then generate a parallel plan. Now, once it generates the parallel plan, a lot of people will think, okay, the query optimizer is done, it's got the parallel plan, but that's actually not true. It then compares the total cost of the two plans it generated, the serial and the parallel, and it will use whichever one has the lower cost. So there are some cases, and I see this occasionally in the help forums, where people will say, my total cost is above the cost threshold, but it's still using a serial plan. In these cases, for whatever reason, the cost of doing it in parallel was actually higher than the benefit it got from doing it as a parallel operation. So it is possible, though rare, for it to generate the parallel plan, but still do it in run it as a serial plan. If you have a system where you're having problems with too much parallelism, but you have a lot of really big queries and you don't want to reduce the amount of parallel threads that they can have, a good way to tune parallelism to increase concurrency is to increase this threshold setting. So the default setting, which is really bad in my opinion, is a cost of 5. So that's a really small cost threshold. And I usually, for a new server, right off the bat, I bump it up to 50. And then if I have over parallelization, I may consider bumping that up. So this would cause these smaller queries to suddenly go serial instead of parallel, so that those small queries take less threads and free up more threads for the bigger queries to go to parallelize out to whatever your maximum setting is. So it's a good way to tune concurrency without decreasing parallelism on the really big queries. Got to talk about CX packet weights. I talked a little earlier about a situation where if you're over parallelizing, you have parallel threads doubling up on schedulers, and so they're taking more time to run. In this case, you may see those long CX packet waits. A lot of the usual response people have to that is to say, "Oh no, CX packet waits, we've got to end that." Go look on forums, you'll see a lot of people saying, "Set max DOP to 1, and all those waits will go away." But CX packet waits aren't what's broken. CX packet waits aren't what you need to fix. They're a symptom of the problem. If you fix the symptom, the problem is still there. The problem is that it could be that your settings are causing things to over parallelize. It could actually be caused by poor disk causing certain tasks to take a really long time to run. It also could be a case of you need to do some index tuning on the queries. Maybe it's doing really big table scans when if you created an index, it could be doing a small, fast index seek and it not have to do so much work. So those are the kinds of things you need to address. Make sure your parallelism settings are correct. And then you also need to look at the query plans and see if it's actually given you a fairly even distribution on the threads. It may, in some cases, SQL Server may, when it splits up threads for parallel tasks, it's usually really good about doing it fairly evenly, but sometimes it doesn't. Sometimes it thinks what it uses to split them up will distribute evenly, when in fact it ends up, because the data is really skewed and it can't tell it from the statistics that it's skewed, it may end up really with 1 or 2 threads doing a big bulk of the work. So that's another thing you have to check. And actually fixing that issue is a really advanced topic, and we're not going to go into that today. But it is something to be aware of, and that there are ways to deal with that are out there. As I say up here, it can be indicative of a query tuning opportunity. Over parallelization is a possible cause of it, and always beware advised to set max degree of parallelism to 1. There's a extremely rare edge case where that's actually a good thing. Probably most of us will never see a system where that's the right thing to do in our entire career. It's only useful on a system where all they ever do are single inserts, updates, or selects. or deletes. If you ever do anything that's set based, do any queries that return more than one row, this isn't the right setting for you. So beware anyone that gives you that advice. And I've actually heard of people getting that advice from people at Microsoft. So don't assume that just because they're at Microsoft that they're correct in this particular case. And as I said, your goal most of the time is to find the right balance between execution speed and concurrency. And in case you were wondering what exactly CX packet waits, it's short for Communication Exchange Packet. Just a little bit of trivia there for you. And so let's take I was talking a little bit about the query plans. And so I want to show you a few things off of those. Now you can see in this little snippet from a query plan here that the tasks have those little yellow circles with the black arrows in them. That indicates that that operation was a parallel operation. And if you click on any of those operations, and you can do it with the arrows too actually, and view the properties, you can expand the actual number of rows tab, and it will show you a breakdown of exactly how many rows each thread handled. The thicker the arrow is, the lines between the operations, it means the more work that was done. And as you see in the property tab will always show you for whichever of these icons is highlighted if you clicked on one of them. And as you may notice in the drop down I have there, thread 0 has processed 0 rows. Thread 0 will always show 0 rows in a parallel task because one thread has to be the watcher. So that first thread that starts and will then spawn the other threads. The other threads will do all the work while thread 0 watches for them to complete and then triggers everything to move forward. So thread 0 will always say 0 rows. Now the database engine still has the option to run with less threads or even in serial, even if it was compiled as a parallel operation. And this tidbit, you can see it has the yellow circle with the black arrows, indicating that it's a parallel, that it was compiled as a parallel operation. But when we expand the actual number of rows, we see here that it says thread 2 did all the work, everything else did nothing. So in this case, it didn't actually spawn a total of 5 threads and with a bunch of them just sitting there doing nothing. In this case, it didn't spawn additional threads, and it just arbitrarily shows that thread 2 is the one that does the work. But it's really only a single thread that was spawned for this operation. So if it is compiled as a parallel operation, but is then run with only one thread, it's going to show you a bunch of threads with 0 by them. So pop quiz time, and realize you can't answer these questions, but just answer to yourself. Looking at this little snippet of a query plan, can you tell which operation did the most work? And the answer, of course, is the one that's thicker. And we can see that by if we click on each of the arrows and look at the operations, we can see the total number of rows for the thin one was 1,529, and the total rows for the thicker one was 262,563. So you can see that the thickness relates directly to the amount of work that was done by that actual operation. Question number 2, what is the parallelism repartition streams operator doing in this case? So there are special operators that you will see that have to be added to plans to be able to process things in parallel. And in this case, we can actually figure out what the repartition streams is doing by looking at the task immediately before and immediately after it. And so in this case, we click on the table scan and view the properties. We can see, okay, it actually ran it in serial, so it got 1,000 rows, and then we do it in the next one. We can see, okay, it actually split it out into multiple threads with the repartition streams. Now, there's actually, if this had been compiled with the table scan being a serial plan, we would actually see a different operator there. If it was compiled as serial, we would see a parallelism operator called gather streams. And it looks very similar, but it's only got one arrow going in on the icon with 3 coming out. And it says, underneath it says gather streams. In this case, it says it would show one single stream coming in, and then it partitioning the data out into multiple streams. Now, at the end of any sort of parallel query plan, you're going to see an operator that says that's going to combine the streams together. So there's going to be a third one. That's I'm sorry. The gather streams is I misspoke. The gather streams is the one at the end that takes all the parallel streams, streams them back together for the end of the query, combines everything together. The other one would be partition streams that takes a single thread and separates it out into multiple streams. So partition streams goes from one to many threads. Repartition goes from many threads to rebalance the load. And then gather streams takes the multiple threads and combines them into one stream. So let's jump to the demo. So we're going to be working on my AdventureWorks DW 2014 database here. And I wanted to pick a big table to work on here. And actually, I added a lot of rows myself to this table. So it's actually much bigger than what you would get just off of the base sample database. So it's actually got a little over 24.8 million rows. So it's beefed up pretty well. So since I have a lot of rows and we don't really care about the data, we don't want to see the data being returned. I've enabled include actual execution plan, and I'm going to just do a count from that table where movement date is January 1st, 2011. And we get a nice parallel plan here. You can see the operators have those little yellow circles with the black dots on it. It's got a gather streams after those parallel operators. It has the gather streams, which combines everything back into a single stream. So you can see the operators there. And if I open up the Properties tab, come on. For some reason my Properties tab isn't opening. Let's see. I ended up here. There we go. Got it open. Okay. So and let's say I'll just go ahead and click on this clustered index scan. We can see the actual number of rows up here is 24.7 million rows. So it's a lot of rows. We expand that. We can see we've got 8 threads that is partitioned up amongst 8 threads. Thread 0 has 0 rows because it's the watcher thread that's watching the other 8. I have Max degree of parallelism set to 0, and I have 8 CPUs, so it's parallelizing out to all 8 of those CPUs. Now, if I run the next query, now let's run that same query, but this time I'm going to use a max DOP of 1 hint to force it to do serial. And we'll see here those extra parallelism operations are gone. There's only 4 operations in this plan. Those little yellow circles with the black arrows are gone. If I click on the clustered index scan, still has the same actual number of rows, 24.7. But if I spread that out, if I expand that, it just says all threads, 24.7 million rows. So everything processed on a single thread. So lots of ways to see that it's a serial operation. Or I'm sorry, that it's a parallel operation. And if we look at the, actually, if we want to see the cost for the whole plan, we can go to this leftmost operator, the select, and just mouse over it, and the little pop-up will show you, it'll say estimated subtree cost. This, if you're on this leftmost operator, it's the total cost for the entire plan. So this plan has a cost of 145.193. Really, it's an arbitrary number for us, but it's very meaningful to the optimizer, and I noted that here, and didn't check, but the parallel plan had a total cost of 104.652. So we can easily see there, you know, that the parallel plan has a smaller cost, and so it makes sense that it chose to do that. So let's take a look at what my parallelism settings are. Oops, I changed my. Take a look at the parallelism settings. Cost threshold for parallelism and the max degree of parallelism. We can see I'm running with the default value 0 for max degree of parallelism and 5 for the cost threshold for parallelism. That means anything with a total cost above 5 is going to be considered a candidate for parallelism. So let's bump that up to a higher number. So let's say 150. Let's say this is a particular query that we don't want to go parallel. So I looked at I ran it as a serial plan, got the total cost. I was like, okay, I need to bump the cost threshold up above that. So I'm going to change it to 150 and run reconfigure. Now don't do this in production during the busy part of the day, because changing the parallelism settings will cause your cache to flush. So you don't want to be playing around with this in production. You only want to change it when you know you're sure. And in many cases, you may want to wait till off hours unless you're responding to a particular problem. So if I run it again and just allow it to go parallel as it sees fit, just let it pick whatever plan it wants, we can see that it picks the serial plan, because the total cost, which was 145.193, is greater than the what is less than the cost threshold for parallelism setting. So it says, okay, this one isn't a candidate, so it's not even going to attempt to create a parallel plan for it. One thing to note, you will sometimes actually get a different cost when it selects it as a serial plan than you do when you force it with the query hint. And it has to do with some very deep internal query optimizer stuff. But just be aware that the values might be very slightly different. So if you are doing it to make sure a particular query doesn't go parallel, you may not want to try to make the number too precise. You may want to add a little padding in there just to give a little bit of leeway so that for it to not be exactly the same number. and I don't have to bump it all the way down to make that parallel again. Let's say I change that to 150 and people now complain about how long this query takes. But I don't want to bump it all the way back down. I just need to bump it down to a number lower than what that total cost is. So if I bump it down to, say, 135, I can now get that query to go parallel again, or at least be considered as a candidate for parallelism, so that if the cost is high enough and the parallel plan has the better cost, it will choose that parallel plan. And sure enough, in this case, it did choose the parallel plan. Okay, now let's jump to something a little different. Let's say I have a user and he's using a SQL account, and his username is appropriately called serial user, but we'll pretend that that doesn't give us any hint as to what this problem is about. But let's say he's coming to you saying he's running this query, and it takes a long time when he runs it, but when anybody else runs it, it runs a lot faster, and he doesn't think it's parallelizing for him. So I say, okay, let me run this as you. I'm going to use it, execute as, to run this as you, and then I'll revert back to my account, and we'll see what happens. So run the query. I say, hey, I'm getting a parallel plan. See, got all those little yellow circles with the black dots on it. If I click on the scan and expand the rows, I'm getting parallel operations here. I don't see what the problem is. He says, okay, let me show you what I'm seeing. And so, since he's using a SQL account, he can easily log into your machine using his account. So he logs in as serial user, and he says, okay, now he's running it with no hints or anything. He says, okay, so this is what happens to me. And the first thing you notice is, yeah, it does seem to be running longer than it ran when I ran it. Quite a bit longer, actually. La la la. Need to make a note to myself to run this query once before we start it, because I think it's probably caching a bunch of stuff right now. And I ran the queries before we started last time. Oops, and I need to choose the actual execution plan. It'll run faster this time because it's not having to cache a bunch of stuff. But it still takes longer than it does when I ran it. And we can visibly see that it takes a longer amount of time, and then we'll take a look at the query plan when it pops up. Should be pretty soon. So we've got the execution plan. It says, well, see, it's showing me a parallel plan. It does seem to take longer, but I'm still seeing a parallel plan. And just to make sure, I click on that first operator, and I expand the actual number of rows, and it only shows one thread. All threads, 24.7 million rows. So even though it's showing a parallel plan here, it's actually doing the operation in serial. And me having seen this before, I said, oh, I know what could be the cause of this. And so I went, hop back to my window, note his session ID is session 55, and then just check to see if his session ID is being restricted by resource governor. So if I run this query, I can see, serial user, yes, he's in a resource group called serial group with a max degree of parallelism of 1 and effective max DOP of 1. So he's being restricted to a single query. In this case, if the user is being restricted to 1 degree of parallelism, it's still going to compile that plan, or it's going to consider that plan for parallelism, and it will make cache the parallel plan for it if it deems that's the better plan, and then but then at runtime it's going to do everything in a serial fashion. So it's still going to look at first look, it's still going to look like a parallel plan, and but it will later be restricted to just one single thread. So I tell him, okay. Let's take a look at your resource group, see how it's configured and everything. Expand resource governor. There's the serial pool, workload groups, your serial group. Let's look at the properties of that. You can see yes, absolutely. It's limited to 1 degree of parallelism. And right now, I'm thinking, okay, I've already spent too much time on this. I don't want to spend any more time on this. I want this person to go away and let me get back to my real work. So say, okay, I'm going to bump you up to a DOP of 4, so you'll be able to run the query a lot faster. The cool thing about increasing the degree of parallelism is in the resource group is I don't need to restart or do anything to get that to work. It will still, when he goes back, it'll automatically run. It'll run faster for him. It's still not going to be quite as fast as it is for me because I'm running with 8 parallel threads, but it is running faster for him now, and it should make him much happier now. And any second now, it should pop up that query plan for us to look at it and see. And if I were to then go, if he were to, after that, if he were to go ahead and try to force it up to a degree of parallelism of 8 himself by using the query hint, as I stated before, it will use the lesser of the two. So he's still going to be restricted to the parallelism settings that I've configured for him in Resource Governor. And if he then comes here and looks at the number of rows, you can see he's now got 4 parallel threads. They're not the most evenly balanced threads, but it is giving him multiple threads now, so he can at least run a little bit faster. But if he tried to use the max DP of 8, it was still only parallelized out to 4. And then, however, if he wanted to say show somebody on his team how long it was taking for the query to run, and it's taking a lot longer than it usually does today for some reason. So I'm not going to rerun this section, but if he ran it with the max DOP of 1, it would limit it down to, it would actually generate a serial plan and run the whole thing in serial. So it does allow it to restrict it to a lower number, but it can't overwrite it to a higher number. So it's going to use that lower number of whichever ones it is. And just being a smart demoer, I'm going to reset my environment and then before heading back to the slide deck. And we're almost done here, which is good because we're almost out of time. Couple other things. As I showed in the demo, parallelism can be stripped out at runtime, but not only can it do it if say it has the resource governor set to 1. It can do it if you're currently experiencing either extreme memory pressure, or running very shorter threads. If you're running out of worker threads, or if you're very short of memory, steps that the database engine, the query engine will take to try to relieve some of that stress is it will start running parallel threads in serial. So if you see a lot of parallel plans that are running in serial fashion, what you're seeing is it's responding to either memory or thread deprivation. And so that's a clear indicator to you that you've got one of these two problems on your server. And the thing to remember is if the cost for the serial plan is above the customer threshold, a parallel plan will be generated, but SQL Server will still use the lower total costing plan. It may be the serial plan. Most of the time it will be the parallel plan, but in some fairly rare cases it will be the serial plan. As you saw in the query plans, it has to add additional operators to the plan, and sometimes those additional operators are enough that the overhead of adding parallelism is more than the cost savings you get from doing the tasks in parallel. So you will see that from time to time. And as I said, it can be stripped out if it's resource problem. So that brings us to the end of the presentation. You got any questions I can answer for you? If you do, just go ahead and, if you haven't already done so, type them into the chat window.
Okay, so Robert, we have just got a question come through, and I'll read it out to you. Okay. So we've got, is there any particular preference with the type of query, select insert update, to be considered when choosing bumping up parallelism?
No, not in terms of type, because any of those queries can affect lots of rows or very few rows. So the type doesn't really affect how you adjust parallelism. It's if you need to adjust parallelism, what you're actually looking for is is to try to get that balance between speed of query and concurrency.
Nazula, are you happy with that? Okay, so yes, thank you, very good. Does anybody else have any other questions? So while you're thinking about that, one of the things that did pop up, and I thought that I might ask you now, Robert, so is there any particular DMV or DMVs that people can use to assist them with the plan costs, or when they're wanting to look at the plan cache?
So yeah, there's actually a lot of DMVs for looking at the plan cache. The one thing to keep in mind, though, is if you're going to look at query plans in the plan cache, those are only going to be the estimated plans. So you'll see the compiled plans, but you won't see how they actually ran. And for when you're dealing with parallelism issues or potential parallelism issues, you really need that actual execution plan, which often means you have to find what query it is that's having problems and then actually generate that actual execution plan by running it to see exactly how it's doing. Obviously, you're not going to be wanting to do updates and deletes and inserts into production systems, so you may need to, like, if you have restore a backup of production onto a non-production server and run it there, and you can compare that to the estimated plan to see that it's generating the same plan, but then you can take a look at the actual row counts. Estimated row counts actually aren't very useful when you're dealing with parallelism. These cost setting are the cost for these operations are very heavily based on the amount of I/O that it thinks it's going to do. So when it generates a cost for a plan, it bases it on how much I/O it thinks it's going to do, which makes it very reliant on having good statistics. So if statistics are bad, or if the data is skewed in relation to the statistics, you can end up with some of these really bad plans where the parallelism has problems. And if you just look at the execution, you see the cost and what it thinks it's going to look, and everything looks fine. But then if you look at the actual plan and it says the cost was like, say, 0.5, but then the actual number of rows was like 100 million, you think, well, clearly that's not right. So it's got a problem generating the plan. It thinks it's only going to be processing a few rows, and you should see that in the pop-up too. There'll be an estimated number of rows and an actual number of rows in the actual plan, and so you can in there you can see how many rows it thought it was going to have to process and how many rows it actually did process. So yeah, you really got to generate the actual execution plan to be able to get the proper insight into parallelism issues.
Hey, thanks, Robert. So while we had that, Cody has asked, what's the methodology for testing whether a max stop or cost threshold change is beneficial for a workload or not? Would you take a replay capture to a table and rerun it at various settings? And what would you be looking for?
Yeah, so if I'm wanting to test it for see what the effect of changing the overall setting would be on the workload, yeah, definitely I'm going to capture the workload session, and I'm going to replay that on a non-production machine with a restored backup of production, and I'm going to test it with the different settings. Another so run it with the old setting, and then run it with the new setting and see what the performance counters are. You're going to want to look at the batches per second and things like that to see how much work it was able to do in a given amount of time. If batches per second is higher, then obviously it's doing more work at the same time. If it's lower, it's doing less. So yeah, exactly. Just capture the workload and replay it in production with the different settings and compare.
Okay, now this one came in just before, and it sort of goes back to your parallelism question. So Cody's just asked again, I've seen advice to analyze your plan cache for parallelized queries and costs, then set a cost threshold, which is about halfway, so that roughly half of your workload is parallelized. What do you think about that?
I've actually never heard the recommendation to set it so that half your workload is parallelized and half isn't. That's kind of an arbitrary statement to make, because they're based. That advice is basically just saying, and it may be based on, okay, this is what has worked for me, and that may work well in some cases, it may not. What I recommend instead, and it is a good idea if you're thinking about changing the cost threshold. Maybe you want to query that plan cache and for the queries that would be affected by changing that setting, just so you can be sure that none of the queries that will be affected by it are highly critical. If you got like some smaller, highly critical queries that really need to go parallel, that may affect what you ultimately choose to set that cost threshold to. So that's actually a pretty good idea to query the plan cache in that way. However, I would say that the part of it that says to make it so that half of your plans parallelizes is really just kind of choosing an arbitrary number to draw the line in the sand at. I prefer to base it upon specific. I find a specific size of query that I think is a good limit for where I think queries should go parallel or not, and I'll base it on the queries I see running in production when it's under stress, and then look at the cost threshold for that particular query and set it to a number a little bit above that, so that that query and the ones um, with the same or lower costs in it aren't going parallel. But there's no way to know in advance whether that will be half of your workload, a quarter of your workload, 3/4 of your workload. There's just no way to really know that where that number is going to fall out in advance.
All right then. Thanks, Robert. Now, if there's no other questions, we have come to the end of today's session. So I'd like to thank Robert for coming along and being our first presenter in the session, in the virtual chapter here in Australia. So yeah, thanks for that, and hopefully you all enjoyed the session. The session has been recorded, and they will be made available so that you can go back and rewatch these from the DBA Fundamentals SQL Pass site. So stay tuned for next month and sign up, and I hope to all see you again next month.
All right, thank you everybody for attending.
Good job. Hey, Warwick.
Yeah.
Before I send out the, I'll send you what I'm going to put in there, and you can look at it before I send out the follow-up for the recording is and everything about the session.
Okay. So I've stopped the recording, so that's fine. I've got a couple of questions. Okay, so that was the number of attendees. So now, I guess, so I changed the presenter back to me.
And when you end the session for everyone, like Robert was saying, you'll get the screen that pops up and says, let's convert it. Go ahead and let it convert it. It does take a little bit. It'll take 15, 20 minutes. And keep that video, and you can play around with it. I'm going to go ahead and take the one that I made, and I'll go ahead and upload it and get everything ready. But what we'll do is we'll use that one as one for you to work with and test with.
Okay.
You might even want to do more than I do. I don't go in and pick a good front, the good icon screen to show. I don't go in and if we talked for 2 minutes beforehand, I don't go in and cut that out. I don't do it professionally. I upload it as we go and go to the next thing, go back to work. So but you might get a little. You might do it and eventually be doing it really nice. I do put some tag words on it. You can be thinking of some tag words to put on it and stuff like that. So anyway,
all right.
I'll let you know. I'll do this stuff tomorrow and send you some stuff out about it.
Okay. Okay, so stop sharing my screen.
And then you can just say end it. And when you file exit, it'll end it. It'll give you an option of end it for just you or for everyone.
Okay. So yep. All right. So file. Yep. And so exit end. Yeah, because if I just leave the webinar. So yeah. So I'll hit the end webinar now. That'll drop you and I off, and it'll ask me for how the content is that I want to save it for.
Okay. Have a good rest of the day, and I'm going to go to sleep.
All right, man. Thank you for today. Thank you for helping me, and I'll talk to you again soon.
Okay.
All righty. Cheers, Steve.